when somebody asks you to solve a right triangle, they're asking you to take the information provided. They'll give you some of the angles, maybe some of the side lengths, and to finish identifying the values of the remaining angles and the remaining sides. In order to answer such a question, you will be using things like trigonometric ratio definitions, like opposite over hypotenuse, adjacent over opposite, that type of thing. The Pythagorean theorem that says hypotenuse squared equals leg squared plus leg squared. The sum of angles, you know, the sum of three angles in any triangle add up to 180 degrees. So we're going to use these facts as needed to answer the question of solving a right triangle. Now in this example, we're given a skate ramp, and you see the actual ramp that you skate down is side C. It's the hypotenuse of this right triangle. The 90-degree angle is opposite that side C. And the bottom, B, is the base of the skate ramp, and then the height of the skate ramp is 4 feet. Now we have a lower angle at the bottom at 18.4 degrees, and then the upper angle on top is labeled alpha. We're asked to find the value of angle alpha, the distance base B of the ramp, and the distance side C, which is the actual ramp itself, the hypotenuse of this right triangle. In other words, we're going to solve this right triangle. We're going to find all the missing parts. Okay, so the easiest thing to start with is the missing angle alpha. We know 2 of the 3 angles. We know that the box represents 90 degrees and the label has 18.4 degrees. We know all 3 angles have to add up to 180 degrees, so we'll say alpha is equal to 180 degrees total minus the angles we know, 90 degrees minus 18.4 degrees. That turns out to be 71.6 degrees. That's the missing angle alpha. Part B, let's find the base of the ramp, the value, the distance of the base of the ramp. Well, if I look at 18.4 and I'm trying to get the value of C, what trig function indicates that we're working with the value, actually the value B, part B is finding the base B, not the side C. Okay, so for base B, you look at 18.4 degrees, and if you know the opposite, not the opposite, the adjacent over the opposite, that would involve values that we're interested in. So adjacent over opposite would be, adjacent is B over opposite 4. You see, that is, B is the adjacent side to the 18.4 degrees, and 4 is the opposite side to 18.4 degrees. And adjacent over opposite is a definition of the cotangent ratio. Okay, solve this equation for B, multiply both sides by 4. You get B equals 4 times the cotangent of 18.4 degrees. And now you pick up your calculator and you run it through there, make sure it's in degree mode. You're going to get 12 feet for the side B. The base is 12 feet long. Now, part C, find side capital C of the ramp. That's the hypotenuse. Now, we want to avoid using values that we derived, that we calculated. See, we derived the value for the base B. We even derived the value for the angle alpha. So you really want to not use those, since you could have made an error, and that error would propagate if you use them. So let's use stuff that was given to us. We could be using, let's see, with accuracy, we could use the 18.4 degree angle that was given to us. We're trying to find C. 4 was given to us, the opposite side, and the hypotenuse is what we're looking for. So it looks like the sine function. The sine ratio says that sine of 18.4 degrees is equal to the opposite 4 over the hypotenuse C. Solve this equation for C by multiplying both sides by the denominator C. You get C equals 4 times the sine of 18.4 degrees. Oh, not times. My bad. It's not multiplying. If you multiply both sides by C, you get C times sine equals 4, and then you divide both sides by sine, you'll get C equals 4 divided by the sine, which we have here. Now run it through your calculator. 4 divided by sine of 18.4, you get 12.7 feet is the distance for C.